Hello,
Hello.
can you hear me? Screen. Uh, can you see the screen?
Yes, sir.
Okay, thank you, thank you.
Welcome, sir.
So first of all, I would like to express my sincere thanks and gratitude to the uh, SIT people or organizing committee of this FTP program for giving me the scope of delivering this lecture. And I also beg apology to the organizer as well as the participants that I could not make me present on yesterday. In fact, there was a communication gap. I thought my schedule to be delivered today, of course, at 1 to 2 p.m. And I had in my mind like that way. So I set my other academic programs on yesterday and could not. Then I beg apology to the organizers as well as all participants for this inconvenience. Uh, now, with this, let's as there were in FDP program, it was that I would be delivering lecture on wireless communication. So within this 1 year, 1 hour time period, what I thought I will just give a lecture on or some knowledge here or my understanding on this wireless communications, 5G and beyond, the issues on spectrum, security and energy efficiency. So outline of this talk, in fact, needless to mention, it's basically this FTA program is some way sustainability of society and that application of engineering field. Needless to mention the importance of wireless communication in today's world in our day-to-day life. And we know that there have been a tremendous progress over the last couple of decades on telecommunication field, particularly in the mobile wireless communication field. And there have been nomenclature like 1G, 2G, 3G, 4G, and 5G, and people are talking 6G, 7G, even beyond like that. So starting from 70s or 80s onwards, then every 10 years or every decade there have been a change in terms of the technology, driving technology, in terms of the promise and the potentials that individual technology likes to provide. If we see the progress and the promise and the potential of mobile wireless communication systems, we will see that in the first generation, around 80s to 90s of last century, what it was basically the coverage dominated. Means whole approach was that there was a high-rising tower, transmitting tower, and high power was used. The objective was as much area to be covered, and there were no security issues because whatever played it was back, and of course there were issues of battery. The charging. It is only supporting 30 minutes of time. Internet were very poor, and mostly it was analog communication scheme or AMPS like communication scheme based on the FDM like technology. Then we move to the next, or the basically what we say that second generation or third generation. The second generation was also objective coverage dominated. Little more data rate was there, and along with that digital data, there was some form of SMS or text data was also there. Then it is basically the capacity dominated in the sense that people were looking for high data rate transmission. So data rate, digital data, uh, voice, along with that there were an attempt to transmit video. Then of course the today's communication world, because all we know there have been tons of carbon emission because of the power dissipation in the base station or the transmitting station or the wireless networks, every time emitting huge amount of I mean carbon dioxide, and has an impact on environmental pollutions. So people are looking for energy efficient communication systems in the means of green communication systems. So the scheme of energy harvesting becomes an important issue. So if we look back, in one side there have been attempt to increase the data rate, transmission data rate. Second thing is latency, low latency, huge volume of data, dense network, massive connection. Along with that, other issues in the communications are green communications. Remember that what we teach, since it is a FDP program, I hope that teachers community are there. And generally, in our initial class of the communication, when we talk about the resource of communication, we say there are two communication resources. One is the power, other one is the bandwidth. So this power plays an important role, and particularly in wireless communications, we need one-way high power in order to reach signal receiver with high reliability. Because to achieve or to obtain high reliability in sense low probability of error, if we see all digital communication systems, we know that signal to noise ratio to be large, so transmission power seems to be large. But again, in wireless communication system, particularly in multiple access communications, if everybody attempts to increase power, so that will create interfering signal to the others. And not only that, most of these devices are handheld devices and they are mostly battery driven, so their lifetimes are limited. We have to have some provisioning of low energy transmission so that network lifetime or device lifetime can be enhanced. Otherwise, we need to replace the nodes, or we need to have frequently, or we need to have some provisioning of energy harvesting. So energy harvesting as a promise of green communication is a very important issue and becomes an important aspect of today's wireless communication research paradigm. Now, as I say that this in this slide, I like to say that how there has been that change or shift of technology from analog domain of FDM or GSM techniques to your CDMA techniques, then your LTE systems, then it is coming like your long-term evolution or 3GPP, or it's sort of things like WebDM based systems, WebDMA or SC-FDMA, single carrier frequency division multiple access techniques. So if we just gradually see, along with that, there have been the massive MIMO technology. I'll be covering some of these technologies in connection with 5G, that why 5G is so much of attractive. And we will see there is a provision potentials of emerging millimeter wave communications. There is massive MIMO, there is NOMA, non-orthogonal multiple access communication, there is scheme of beamforming, there is scheme of mobile edge computing. So all these collectively makes 5G attractive. So if we just see in the next slide, I like to say that how there have been change from data rate 10 kbps to some sort of 50 kbps, then it is 384 kbps, then 5 to 10 megabit per second, then we will be looking for 100 megabits per second of 4G, and now we are expecting in 5G that to be 100-fold increase of today's scenarios. That means what we are getting of 4G at 100 megabits per second or something like that, our expectation for 5G should be 100-fold increase of that one. And along with that, the diverse traffic modalities are coming into the situation. As I say, in the first generation, particularly in 1980s, where it was only very low voice communication of analog mode, and along with that, there was some digital data in terms of SMS and others, then gradually coming voice and video. So we can see from second generation or 2.5G that how data rate changes and voice plus data, voice plus data. And in 3G and 3.5G, we see that voice data, along with that, there was video calling, and eventually the data rates are also from 384 kbps to 530 Mbps. Then we go for the fourth generation, where it's a long-term evolution, 3GPP systems, and 100 to 200 megabits per second. And the facilities of the data traffics are voice, video, data, online gaming, HDTV, etc. But when we see the 5G, this 100 to 200 megabits, which we are expecting to get at 4G, it had to be multiplied by 100 folds. So some range of gigabits, 1 to 10 gigabits data rate we are expecting in 5G. The power consumption is a very important issue we need to consider because these handheld devices, our mobile or laptop or other electronic devices which acts as a node or IoT devices, this seems to be battery driven and it should have a limited lifetime. So we need to have energy consumption. We need to focus on low power communication systems so the energy dissipation would be less, battery drainage will be less, and it would lead to longer time duration of network and hoping the scope of energy harvesting from the non-conventional energy or from the RF signal of the uh, tower, I mean the base station tower, TV tower, or other electronics transmitter systems. So what 5G other way like to, that means the requirement or the expectation in 5G data rate of the order of 1 to 10 gigabits per second, and battery lifetime should be tenfold, means whatever we have the battery lifetime 2 days, it would be enhanced by tenfold so that energy consumption should be reduced by a factor of 10%. Latency, that means end-to-end delay, should be of the order of milliseconds. So it should provide some sort of real-time flavor and huge volume of data topics. I mean, expect that a user will handle 40 terabits of data per month, or you can expect that there will be billions of nodes to be connected worldwide, seamless connectivity. So massive connections, one sense, ultra dense network and ultra reliable network. So if we can say 5G, we can talk about three important things. One is the massive connection, ultra dense network, and ultra reliable networks. That's the promise and the potential of 5G. That sort of things I'm going to say here. Now the question comes then, of course, the device to device, I'll touch upon all these issues. The question then comes, what makes 5G attractive? What are the driving technological force that makes 5G attractive? So this is the question, what makes 5G so exciting? There are 6 points that need to consider that makes 5G exciting. One is the millimeter wave communication. The communication channel is something like, if you consider a transportation problem, the civil engineering background people, if you can think about, particularly the communication engineer can think data transmission in the framework of transportation of civil engineering. As we know that if we have a high road, if we have a wider road, the vehicle should have high velocity or high speed. Same thing, if we have the wider bandwidth, large data rate can be transmitted. So millimeter wave, we will see that 24 gigahertz to or 100 gigahertz, this frequency range assumed to be of millimeter wave communications, and that large bandwidth, high frequency is capable of transmitting high data rate, carrying high data rate transmission. Of course, there are challenges. Millimeter wave communications suffer from attenuation. It has form of, wireless channel modeling. These are very challenging. Existing electronics hardware needs to be developed. So there are challenges, but the promise and the potential of millimeter wave communications, that high data rate transmission is possible. The second issue is massive MIMO, multiple input, multiple output. There are more number of large number of antenna. You will see that MIMO provides 2 types of benefits in terms of data rate transmission. One is spatial domain, spatial multiplexing, and as well as the diversity. Diversity means creation of independent path. So if one of the wireless path is weak, the other path can take care. So from transmitter to receiver, there will be multiple wireless path establishment. And if one path is weak, so the receive signal is weak, the other path can take care of. So the diversity, creation of independent path, this provides, so MIMO provide 2 types of benefits. One is the diversity benefits, other one is the spatial multiplexing. As a matter of fact, the data transmission rate enhanced manifolds. So second aspect is MIMO. The third aspect is your beam forming or small scale, a small cell. So instead of considering a larger cell and wide coverage, we can go for smaller cell. We can restrict the transmit power. We can control the interference, and that way we can reuse the frequency. So a kind of frequency reuse by means of small cell is possible. Other thing is your beam forming, because if we have an omnidirectional antenna, if the signal transmitted in all directions, after a certain distance coverage, its strength go on reducing. And in that sense, it's not much of effective. Rather, if we go for a beamforming, that means if the signal is directed towards a particular receiver direction, which is very essential in physical security. We'll be talking about that the physical layer security, a kind of signal processing means by means of beamforming, this security can be provided. So beamforming plays an important role for directed transmission of signal and saving the energy reduction rather than of omnidirectional communication. So beamforming is another issue. And then mobile edge computing is another issue. Another issue is NOMA, non-orthogonal multiplexes. So let's see, these are the points as I say. One is the millimeter wave communication. Millimeter wave communication, I talk about that 100 gigahertz, so 24 to 100 gigahertz, which proposed for 5G. So basically it is your millimeter wave range. Actually, eventually it is the 300 gigahertz. Roughly from 30 gigahertz to 300 gigahertz is for millimeter wave communication. But there are challenges in above 100 gigahertz, the electronic system maturity, development, and channel modeling, loss. Loss is very, very important things because the high frequency, or as all we know in physics, that the frequency and bandwidth product is the velocity of the light. So as you go on large frequency, the lambda, the wavelength values would be very, very small. And lambda small means the size of the antenna should also be small, because size of an antenna depends on the operating frequency. So when your wavelength of the frequency is low, the size of the antenna should also be low. That means in a transmitter system or a receiver systems, we can mount large number of antenna, or in a base station, large number of antenna can be mounted, which can support many data, or many nodes or many users. So that benefits is possible in terms of MIMO, and basically that benefits we get from the benefits of millimeter wave communication. So millimeter wave communication, the merits or the advantage is high frequency, so it allows large volume of data transmissions. More number of antenna can be mounted. So that's the basically the advantages. But disadvantage is attenuation is high. That means it is blocked by wall, or it is blocked by trees and obstacles. So this is basically the absorption and attenuation is very, very challenging issue. I mean the negative sides of the millimeter wave communication, because you can see that, as I say, lambda being very small, and let's say dust or tiny particles or water droplets, which are of the order of same radius, and they absorb the signal severely. So attenuation is very high in millimeter wave communication. So, that sort of things, the disadvantage is in millimeter wave communication. And in large antenna area, as I say in massive MIMO, the two benefits: one is the spatial diversity. Spatial diversity means the multiple antenna in the receiver, so creates an independent path. And if one of those signals, receive signal is weak because of the poor channel condition, that can be taken care by other one. Or we can go for a combining scheme of multiple receiving antenna signal, and we would have a stronger signal. From there, we can have a good decoding reliability. And spatial multiplexing is another advantages. So the relationship between the wave frequency and antenna size inversely proportional. I already say high frequency, so smaller antenna, large number of antenna can be used. Then disadvantage already I say that higher frequency signal we have more collision with obstacles and energy losses. Millimeter signals can be easily blocked by the trees, buildings, etc. So you can see here is that this is obstructed and these are all obstructed. So the signal specs become weak, it cannot penetrate this one. So what we can do here is that we can go for erecting small tower, and we would have a smaller coverage zone. So it's sort of things like small cell concept that have been told in the next, shown in the next slide. So if you having a small cell, now you can have a small coverage, you can restrict the power, so there will not be interfering effects, right? So these small cells are used to fill the coverage gaps between the base stations and the users, right? Now beamforming, as I already told, that for electromagnetic wave, if it is omnidirectional means if it is directed in all directed spherical mode of propagation, and it can interfere with the adjacent signal spreading and large, the loss is very high. Now, if we just sort of things you can see here, that user 1, user B, user C, they are being close by, so they can create an interfering effect, and different user might interfere with each other, and if they are standing close. Now, this problem can be overcome by means of a kind of beamforming operation. You can see here that if we have a very directed beam, then it could have a easily penetrating, it can overcome the interfering effect. So beamforming makes that transmission between user and base station more directional. You can think of like that. Let's say, for example, secure communication. This is an Alice-Bob communication, and this is the IPS, what we say in cryptography or in security. So what would happen if we have a kind of beamforming, and as it is providing reliable connection, so if it is, let's say, Alice and this is Bob, and Alice-Bob communication, rather than this kind of configuration, if this beamforming is done, so it is expected that we would have a good signal strength for desired user. On the other hand, this, forget about that, this beamforming is not this beamforming, and there is no beamforming facility for eavesdropper. So, or eaves, so you will not get the signal. So by means of this beamforming techniques, I will come in the latter part of my talk when I will be talking about the physical mode of security, that this beamforming, one way possibly create a bad channel and good channel. Beamforming creates a good channel for the desired receiver and a bad channel for the undesired receiver like Eve. And by that way, it can provide a good signal and bad signal for the receiver, undesired receiver, and provides a kind of security. So beamforming, a kind of signal processing approaches, plays a very, very important role in providing the physical layer security in data transmission. Then we would have NOMA, non-orthogonal multiple access scheme. You know that in, as I saw at the beginning, that communication resource are power and bandwidth. Bandwidth are natural resources, costly and scarce resources, like our natural resource, air, water, which gets polluted. Spectrum also gets polluted if there are data congestions. If huge data transmission and less amount of spectrums are available, so your spectrum would be congested. And spectrum is a natural and costly resource. You know that 5G, when bidding was there, or in the other cases that earlier in the scam, you see that spectrum is very costly and scarce resources, and it needs efficient utilization by means of multiple access techniques. So spectrum sharing is a very important issue. Spectrum management is a very important issue. The promise and the potential of IoT, you can expect that billions of nodes to be connected and seamless connection to be provided by means of channel or frequency allocation. How it can be done? Because spectrum is a scarce resource and a limited resource. If there are unlimited number of users or millions of nodes to be connected, how this limited resource to be shared? So you need to have an intelligent sharing mechanism, and that to be possibly done by means of different multiple access techniques, like your time division multiple access techniques, where the time is divided into slot and each slot is assigned for individual users. We would have frequency division multiple access techniques, where the frequency bands are divided into smaller slots, or it could be CDMA techniques like code division multiple access techniques, where orthogonal codes are given to the individual users, and users' codes are orthogonal, so they would not be interfered with the other one. On the contrary, so all these are orthogonal multiple access schemes, whether it is a TDMA, FDMA, or CDMA. But these days there is in 5G NOMA, non-orthogonal multiple access techniques, by means that in a time or in a particular frequency or subcarrier or spreading code or space to be used by multiple users simultaneously. A block of communication resources, that communication resources may be time slot, maybe subcarriers, maybe spreading code, maybe space, that to be assigned to multiple users by means of power control. Let us assume that in a particular time, in same time, same frequency given to 2 or 3 users. Now, different powers are used. The different users able to use different powers, and that power basically can be interfering with one with respect to the others. So, in non-orthogonal multiple access techniques, by means of 2 users having 2 different power level, the higher power level users signal to be effectively or reliably decoded. Once it is decoded, from the summing signal, from the composite signal, cancel the interfering effect of one user and improve the quality of the other user. So a kind of multiple user detection scheme to be used, and that way it provides the benefit. So NOMA provides a higher throughput, low transmission latency. Latency means end-to-end delay and signal cost than orthogonal methods. So this is one attributes add to the 5G making attractive. And finally, the mobile edge computing. That's an important issue. Or we know that we have a cloud environment for computing and storage facility to avail, but the conventional clouding environment has problem is that it is a physically large separating distance with respect to the end users. Whereas mobile edge computing provides a platform where this computing facility physically comes closer to the users. And application, some of the data or application when it needs to go for downloading, it takes the space of the end user may not be sufficient because of the the limited power and memory. There would be a problem when you are going for downloading some data or applications. Mobile edge computing provides that facilities. It can split the works, and some part of the works to be done in the cloud environment, and some can be done at the end user environment. So that's basically your the benefit. So as I say that mobile edge computing, this one is normal cloud computing environment. Cloud servers are generally far away from the user physically, which increases the latency. And data and application, as I say, the downloading needs user devices which may not have sufficient that burden of because of limited power and memory. So mobile edge computing brings cloud computing and services to the edge, which are physically local to the users, right? And applications can be splitting in parts, and some parts to be done at the cloud environment, and some to the end user. So that's the facility. So now coming to this end, that we are having scarce resources. We are having resource constraints. This resource is basically the bandwidth resource, because the promise and the potential of IoT and others demands that there are billions of nodes to be connected worldwide, seamless connection. We need that huge amount of bandwidth. But bandwidth is costly and scarce and limited resource. So we need to go for an intelligent communication systems. That means the limited spectrum to be intelligently utilized or shared by different users. So 5G mobile data traffics are increasingly random and diverse. Increased number of wireless users with data intensive application, scarcity of radio frequency spectrum. Other, as I already say, that energy is an important issue because these nodes are battery driven, has limited power. Either you need to make a provisioning of frequent replacement, or you need to have sort of recharging facilities and others. So energy crisis is very, very important. And of course, long distance coverage, when it is the issue, we have to go for relay-based communication system. Means when transmitter and receiver cannot see each other directly, that there are line of sight communication is not there, or it is a longer distance away, we need to go for relay-based communication. And that relay-based communication is power efficient or energy efficient, provides communication. But when relay are there, you can see when you make use somebody for communicating your message to somebody else, that there is a issue of security. If you say directly to the receiver, whatever security you can establish or maintain, when you say this via by some other people, the security becomes again more issues. So relay-based communication or copper communication eventually creates a security threat. So if we see the current communication environment, there are energy crisis, there are spectrum scarcity, there are issues of security, and high data rate transmission, long distance transmission, multi-hop routing. So multi-hop routing means the source to destination, there are multiple links. And if one link goes down, so end-to-end communication may not be reliably possible. As I say that energy crisis, that means energy harvesting should be there. Transmitter circuit itself will make use of the radio frequency signal or wind, solar signal for charging its battery. I already said the millimeter wave communication can be one wave to provide high frequency. And now I will be talking about the concept that's called cognitive radio. Now you see, I told in one sense that spectrum is a scarce or costly resource, it is a limited resource. And current mode of frequency allocation, if you see the government of India or any common countries, the regulatory bodies of the frequency, they allocate this frequency to the different user for particular communication. So for example, if we see that our police communication, police radio communication is our AM/FM broadcasting has one frequency, allocated frequency, or TV broadcasting has certain other frequency range. So 1 to 10 gigahertz frequency range almost crowded because of the different frequency allocation of different services. But if we see that most of the cases, these frequency are underutilized. So for example, if we see our northeast part of the country or northern part of the country, do you think that televisions are sufficient number of channels are there? The allotted frequencies are extensively used? No. So the frequency are underutilized. That means there are licensed users, say for example, Reliance purchase frequency range or frequency band from the government of India, but it may not have sufficient amount of data to transmit. So the frequency is underutilized. Now we have lot many communication to establish. In one hand, we demand spectrum. In other hand, we see the allocated spectrum because of the static mode of allocation is underutilized. So can we go for a kind of cognitive communication scheme? That means we will see that the licensed spectrum, like say Reliance is the licensed user, the primary users who are really using a particular spectrum or not. If not, then why not this to be opportunistically used for communication of other purposes? So that gives rise to a concept called cognitive radio communication. Cognitive radio communication is an intelligent wireless communication system where a transmitter, basically a secondary user, means who does not have any licensed frequency for data transmission, intelligently sends the spectrum occupied by the primary user or owned by the primary user and find whether whether the spectrum at a particular time is free or not. If it is free, then it can opportunistically make use of it for transmission of its own data. So spectrum, as I already said, is a scarce besides a natural resource and public resource, both get polluted with data congestion. Here in cognitive radio network provides green communication. Why it is called green communication? Now it provides green in two senses. One is it takes care of the natural resources like spectrum, and it also looks for power efficient or energy efficient communication, and by that way it can talk about the environment. The important issue of spectrum, data transmission is spectrum sensing. Means you sense, as I say a few minutes back, that there is a licensed user who is having a ownership of a particular frequency, but there are unlicensed users which we call as secondary user. Secondary users will access primary user bandwidth in an intelligent way. So for that, what secondary user will do? Secondary user, before data transmission, first sense that whether primary user frequency at this particular geographical location, at this particular time slot is used or not. Whether primary is using its frequency for data transmission or not. If not, that secondary goes for its opportunistic data transmission. Right? So that is basically cognitive radio. A radio that can adapt its transmission, because if it finds that primary or licensed user using this much of spectrum, then it has available bandwidth this much. Depending on the use of the spectrum, secondary may have a particular or a certain amount of bandwidth free for its transmission. So accordingly, it has to control its data rate. It has to change its signaling rate. It has to change its data transmission mode. So radio communication, it's an intelligent wireless communications where a transmitter, before transmitting data, sends the radio environment and based on the available resources, control its data transmission by means of signaling techniques, by means of power control and others. So this is basically your cognitive radio communication. There are, as I say, these are the cycles in the cognitive radio. That this is the radio environment, radio frequency spectrum. Before a transmission, it sends the frequency. Spectrum sensing is basically a binary hypothesis. What does the spectral sensing like to mean? That a radio frequency signal, a receiver or a transmitter, before data transmission will sense. That means it will receive the radio frequency signal and detect whether the radio frequency signal is truly or a valid radio frequency signal or a data transmitted signal or a noise-like signal. That means a secondary user makes a binary hypothesis that whether primary is currently using the spectrum for data transmission or not. So spectrum sensing is nothing but resolving a binary hypothesis, just like those people work in an image processing and talk about a pixel, whether a pixel is an object pixel or a background pixel. It's a kind of hypothesis. Similar things like a target detection in radar. When you send some electromagnetic wave, and if there is a target, the wave will be reflected back. And if there is no target, it will not be reflected back. So it's kind of binary hypothesis resolving whether the spectrum is currently being used by primary user or licensed user or not. Then you make the decision yes or no. So if primary is not transmitting, that means we call it as a spectrum hold. So secondary can make use of the spectrum hold for its own data transmission. Now it can go on sharing. Suppose there may be a situation when primary and secondary simultaneously using, at the same time using the same frequency, but they control their transmission power. Like in our, in a room, when we talk about among each other, we restrict our power so that my receiver can only get the signal. It will not interfere the other communication parties. So same way, we could go for a spectrum sharing. That spectrum sharing, there are different modes of sharing: interwave mode of underwave, overlay or underlay mode of communication. So spectrum sharing and spectrum mobility. Spectrum mobility means you have to switch from one frequency to another frequency, because suppose time being the primary is not transmitting over a particular frequency and secondary finds it's free, start communication, but its communication not completed. By this time primary we are getting control of transmission. So this frequency secondary has to make free, but secondary needs also communication to continue. So it may have to look for another spectrum hold. So spectrum mobility is very, very important. Particularly in IoT-like communication, where there is a mobile mobility is there, you may have to switch from one communication frequency or channel to another channel. So this is basically your primary, the spectrum mobility. So this is basically a kind of spectral or cognitive cycle. Cognitive in sense radio frequency cognitive cycles. As I already said, there are two party, basically the player, primary user, which is licensed user, who is having, like say Reliance, having certain access of the particular frequency. We can go for secondary transmitter by opportunistic transmission. So we need to do spectrum detection or spectrum sensing. Spectrum sensing, as I said, is a binary hypothesis, and there are different techniques used in the existing literature. I am not talking about all this. Energy detection means whether RF energy signal. So secondary, for detecting whether primary signal is transmitting or not. So it will do one thing, that secondary or unlicensed user will measure the energy of the received signal. If the energy of the received signal is above a certain threshold, it can say, well, primary is transmitting. Or if the energy of the received signal is below a certain threshold, it can say, oh no, it's not transmitting. There are other concepts like called match filtering. That means if the secondary knows the primary signaling pattern or primary signal transmission pattern, so just like your fingerprint identification problem, if you have a template, so you can correlate with all other fingerprints template and find the maximum correlation. So match filter is something like that. If you have knowledge of primary user signaling pattern, so you can go with correlation and find this. Then there are cyclostationary frequency, features detection. That means if you know some features of the primary user signal, so secondary make use of that features and may go for detection. Or a kind of log likelihood ratio test means there are different log likelihood ratio test means a kind of ratio test, conditional probability like, and based on that it can detect whether primary user is present or not. So this is basically a binary hypothesis resolving. I'm not going to that. So this way one can go for intelligent spectral access. Now second question comes, which is the part of my talk, is security. When we call about the information security, most of the cases the people notion goes to the application domain security. That's the cryptographic technique. Before coming to that, why the security aspects comes into the situation, particularly in wireless communication? Because of the open nature of the wireless communication. When Alice like to talk with its desired receiver, the Bob. So Alice Bobs are desired communication party, but because of this wireless channel, the Alice Bob communication will also be received by Eve. So Eve will also eavesdrop and get the message of this Bob. So eavesdropping. Or it can create a jamming. So eavesdropper may be a passive eavesdropper which can listen the communication, or it can create a jamming signal to interrupt this communication. So this is jamming attack. So eavesdropper may be a passive in sense that it will only listen, or it can create a jamming signal to disrupt these communications. That is best possible because of the wireless channel. Now, I talked about a few minutes back that cryptography. The cryptography, when I just talk a few minutes, the uh, main points of the cryptographic techniques, that we generally have a plain text and we make use of some form of key, symmetric, asymmetric, or public or private. That's of key. That key is used for making this ciphertext, plain text into ciphertext, and making use of this key at the receiver, the ciphertext go back to the plain text. Now, this is involvement of application layer. What we need to do? Use key, and key management becomes an important issue. Now, other thing is lots of computational tasks are done, and that computational tasks done by these nodes. Nodes are power having limited power. So the issue now comes that a computationally expensive jobs to be done by this tiny node which is having limited battery. So this going against that. Not only that, what the communication likes to see that if the key is not available to the Eve will not be able to decode. Right? Now, when Alice-Bob communication was there, can we define that this much of data was transmitted and how much was securely transmitted? So in cryptographic techniques, the whole things boils down under a basic assumption that Alice and Bob are equipped with high computation, whereas Eves do not have that much of computation. It works like a concept or an assumption. So at high levels of protocol stack, cryptography is used, and based on the assumption that limited computational powers are available at Eve and vulnerable to large scale implementation like quantum computing and others. Similarly, if we see the communication domain in the physical layer communication, those who are familiar with spread spectrum communication or CDMA, you know, a spreading key is used, and that key, if not known, the decoding will not be done. So despreading operation to be not done. So that's why one kind of security is provided by spread spectrum techniques also. That's basically low probability of intercept or LPI or a kind of camouflaging done by the spread spectrum techniques. That means the message signal spread larger than the minimum bandwidth requirement by means of using a spreading code, and at the receiver, despreading is done by using the same spreading code. Now, here also one assumption is that let's say in Alice-Bob communication, they make use of spread spectrum techniques. There are different types of spread spectrum: time hopping, frequency hopping, direct sequence, charf, and others. That way one can go for providing this kind of security. But the question again here is that if does not have any knowledge about the spreading codes. So it also works on the assumption, and it is done on the physical layer, vulnerable to rough or captures of known events. So there is also. Now, information theoretic security or physical security, on the contrary, says that, okay, it just sort of things like, go back to our security aspect. Say in our early days, our homes are not properly locked. It was kept open. Now what we are doing to protect it, we are using more and more lock and keys and 5 levers, 7 levers keys and all this like. So basic things are what? If it can be done, say for example, if I have a room, but I keep my room open, and along with the precise materials like say gold, if I can put some ornaments which is similar like gold but not. So when a thief will enter, he will be confused whether it is in gold or it's not, false or something like true or, some confusion to be done like that. So what we like to say is that when Alice and Bob is communicating, so this is the nature gifted wireless channel. Why don't we make use of this wireless channel? That means if I can do good signaling scheme such that the signal received by Bob is very good and signal received by Eve is very bad. Now you say, bring about your notion from the cryptography that suppose if this channel is very poor, Eve will get low signal to noise ratio. So it will be having large probability of error. As large probability of error, message decoding will not be reliable. So by means of power control, by means of providing good and bad channel, because wireless channels are God gifted and the nature given, and by means of signal processing, by means of communication techniques, by means of power control, if we can establish a good channel between Alice and Bob, And if we can create a bad channel between Alice and Eve, we can provide security. And that's basically your information security, information theoretic security. So it is done at the physical layer, no assumption of Eve communication power, no assumption of Eve communication information available. It is unbreakable. You cannot break. Provable means you can prove mathematically, yes, security. Why prove mathematical security? Now, if I can create a good channel, the channel capacity of this link should be larger than the channel capacity of this link. That means data rate in this link is larger than the data rate. And the difference between these two link data capacity is the secrecy measures. So it can be proved mathematically that if I can create a good channel and if I can create a bad channel, so data rate at this channel would be larger than the data rate, and we can establish or we can prove security. So that's why it is provable and quantifiable. Means Alice and Bob communicating some amount of data. Out of this, how much is securely received by Bob? This can mathematically be proved. So that's basically your unbreakable, provable, and quantifiable. Means one can quantify that is certain amount of data when communicated, how much of amount of data to be securely received. And it can be done by means of signal processing. So combining all, but nevertheless, I don't like to say that there is no need of cryptography and physical layer security is the only means of like that. But if we can have a multiple access, if we have a multiple layer approach, cross layer approach, that means we can make use of simultaneously cryptographic techniques and physical layer security. So tightening, we could have a more security aspect to establish. So all these multi-dimensional, multifaceted and cross-layer security approach may be the approaches to be used in future. And in fact, people are looking for like that. Not the cryptographic techniques only, not the physical layer security only. It's the amalgamation of cryptography and security from the application layer as well as the physical layer. And that to be the engineering used in the future. So physical layer security means Alice and Bob, as there are multiple antenna. So this is a good signal and that's a bad signal. So this is the word tabling. Upper layer cryptographic techniques may consume high energy, as is the case. Because see, why we are putting notion on physical layer security? Cryptography is computationally expensive, consume enormous power. Nodes are battery limited. We cannot give this much of burden to the node. We will be looking for avoid cryptographic key management. We will be looking for information theory. So main idea, as I say, wireless channel characteristics to secure wireless transmission in presence of. I already told that you need to create a good channel, you need to create a bad channel, and that way you can make establishment. So a secrecy capacity, as I say, the difference between the main channel capacity and eavesdropper channel capacity. And if this difference is positive, we can prove mathematically, yes, it's established. So secrecy capacity is what? The capacity of the difference between the main channel and that of the wide-tape channels. Now, if this value may not be always ensured, let's say out of 100 times, 90 times, this value is above a certain threshold. This difference is above a certain value, or 10 times is below. That means outage probability is 10 by 100. That means when this difference or SC falls below a certain rate RS, then that's the outage probability. And that is a measure of communication channel. If in your communication environment, if you can establish that outage secrecy probability is very, very small value, you can say that Alice-Bob communication is secure as far as eavesdropper is present or not. In presence of eavesdropper. So this is basically, and now you can see how this to be established. Say, for example, here a secondary user, transmitter and receiver, they are communicating, and this is the eavesdropper. Eavesdropper is eavesdropping. Now you are using some people, the jammer. The jammer is not a friendly jammer. Something like that. Say in our meeting, sometimes when we do know that when we hire some people or we manage some people, okay, when some discussion will be there, you just make a chaos, you just make a sound so that the communication will be disrupted like that. So here it is, Alice-Bob communication, it's an Alice-Bob communication is there, Eve is there eavesdropping. Now you are having some sort of jammer. This jammer signal is a priori known to this. That means what coding pattern they are using. These are friendly jammer, so they all know. I mean, this Alice Bob know the coding pattern of this jammer. Now, when the communication is going on, that means Alice is communicating message and jamming signal. So Bob is receiving this signal as well as this signal. Since a priori Bob know this signal, from this composite signal it subtract and get the message of this one. On the other hand, Eves do not have this knowledge and this knowledge as well. So it is having composite signal. It fails to decode this signal and that signal. So this way, a jammer can make use of its power signal or make use of its power to jam listening of this eavesdropping. So it establishes the security. It helps in establishing the security. So this is basically countermeasure. In physical layer security, so no limitation of communication, as I already said, no information. We are able to provide secrecy to the labor. What is that? We are able to provide secrecy to the legitimate user. Secrecy to the legitimate. We seem to be at mercy of nature. What that is like to say? Now, wireless channel, the nature-given channel, we can make use of these benefits. That means we can need to create a good channel or a bad channel, and that is done by means of signal processing and your beamforming techniques or communication scheme like multiple antenna, signal alignment, as I said, the beamforming, time and frequency, and diversity techniques. So we need channel advantage. Can we create channel advantage? Yes, this way we can do it. I'm skipping all this. As I say, other issue is the limitation of the battery power. So we need to go for harvesting. There are enormous radio frequency energy because we are having a large cell phone, radio towers, Wi-Fi towers, laptops, TV signals, lots of are there, and they are emitting continuously radio frequency signal. Why don't make use of this radio frequency signal for energy harvesting? Some sort of things like frying the ILSA fish. It can make use of this own oil for frying it. So sort of things like that. We can make use of this RF signal and our mobile, let's say in one day, we should have a provisioning in our mobile phone. Rather than plugging it in for charging, this mobile phone will receive the radio frequency signal, and from there it will harvest energy and it will charge the battery. So it could be a kind of self-powering scheme. So energy harvesting, as I say, it's basically an RF to radio frequency DC conversion, then power conditioning, a kind of rectifier circuit and all this. Nothing else. I'm not going for this. So battery lifetime can be enhanced. We need not have to replace the battery at regular interval of time. Or it should have a self-powering arrangement. Or we can make use of the non-conventional energy sources like solar, wind, and all these thermal for harvesting purposes. Now we'll just one or two, three system design I'll be talking about, like say joints. So this is basically a spectral sensing and data transmission with energy harvesting scheme. Here is the license user, say for example, using the Reliance spectrum, and this is the secondary user, this is the secondary, I mean the unlicensed user communicating, and they are not directly communicating. There is a relay for power efficient communication, and this is the eavesdropper. So what we need to do basically in our communication systems, we need to harvest energy. These are transmitter battery will be drained, so it needs to go for harvesting. So this signal will be used for energy harvesting. It has to decide whether primary is transmitting at a particular time or not. That's called spectral sensing. When it finds that spectrum is free, then it will transmit data to the relay, and in the next time slot, the relay will transmit the data receiver. So what is the scheme? Now you should have a time frame. In first part of the time frame or first time slot, that energy harvesting or spectral sensing is done. And based on the decision of the spectral sensing, that means spectral sensing says that primary is not transmitting, so it will transmit data like that, or it will go on harvesting. If it finds that primary is transmitting, so it can go on harvesting. Like this way, different framework can be done, that some of the secondary throughput or secrecy to be established, or it should have the energy. So by means of different way, basically in our work, we have done that large number of secondary nodes are there. They are sharing their communication to the respective receiver, and some throughput should be above a certain limit that to be ensured in this work. And in other work, what we have done, not only, I mean, in previous work we say energy causality. That means whatever energy it will harvest, the whole to be used for communication purposes. But here in this work, we are going for residual energy maximization. There is again the scheme that primary user and primary receiver, secondary relay and secondary multiple eavesdropper are there. That means only a single eavesdropper are not there. And this eavesdropper exchange their information. So the secrecy will be more challenging because this time not only one eavesdropper, multiple eavesdropper are there and they can exchange the information and whereby they can decode the communications, right? So here the secondary transmitter like to harvest more energy and keep some of the energy as residual energy so that it can be used in the latter part, and that way network lifetime can be more enhanced. Here you can see that scheme or system model use multiple eavesdropper, but here the scheme is multiple jammer but a single eavesdropper. Now what would happen? You can say why multiple eavesdropper. Now if this eavesdropper, this jammer and this eavesdropper, there is a one wireless link. Whereas this jammer and this eavesdropper, another jammer, wireless link. So these wireless links are stochastics in nature, non-stationary. Wireless links are good and bad. So if this is a poor channel, this jammer might create more interference than this jammer. So out of these many jammers, there is a question of selecting a jammer. Jammer selection is playing an important role so that eavesdropper cannot get the message of communication, or you can protect secondary communication from the eavesdropping operation. Right? There is other works where we have done. There are say for multiple eavesdropper, they exchange their information to a fusion center such that a good decoding signal can be done, and instead of there are different types of relay are used, and that way we can multiple eavesdropper protection from the multiple eavesdrop signal, the protection of this communication from the multiple eavesdroppers. Now the last is basically system model which is used for UAV, unmanned air vehicle systems, and is a part of this intelligent industrial IoT systems. Where what we have done, we are selecting a best jammer such that, say for example, two companies, factories, offices are close by, and they are communicating. One factory communication is going on by its own network, and another factory, both are having the same communication, a business interest. So it might be getting the communication of the system, the factory A. So factory B might have an intention to know about this, and in order to make it eavesdropping operation, protect this eavesdropping, factory A make use of this jammer, and the jammer can make use of jamming these signals, right? Finally, we will be talking about one that how the machine learning scheme is there. As I say that spectral sensing, you need to sense spectrum before data transmission. But when you do the sensing operation, your power will be consumed. So it is a power consuming, and it will also take some of the time for sensing. So data transmission will be overcome. In one of our work, in the very recent work, we have done spectrum prediction, and here is a base station, here is an end user, these are the primary user, these are the secondary users. They are providing short distance communication by means of device to device communication. Here this device, before transmission, whether the communication channel is free or not, it predicts. That means at a particular time instant, when it will transmit data, whether it will get a free channel or not, it will predict that spectrum. And system model comprises of so that basically a spectrum prediction scheme by means of reinforcement learning, a machine learning based approach. We have a couple of works in our research group using machine learning for this communication, and machine learning to be used for resolving the wireless channel condition and others. I'm not going to the extensive part of that. So basically it is having a kind of original primary user spectrum usage pattern, and it is basically the prediction pattern, and depending on the situation, a secondary, a device to device, here the objective is it will maximize its energy efficiency. Energy efficiency means that data transmission divided by power consumption. So energy efficient communication means using a given power as much data to be transmitted as possible. So basically energy efficiency maximization subject to certain constraints. The constraints are power constraint, constraints are data constraint, and interference protection. So this is one system model where machine learning based approaches are used for. Now I will end because I'm going out of time. I think I should not go further more. That's the part that technical challenge is in 5G communication. as I say, the millimeter wave communication, there are lots of ingredients or challenges of channel modeling. So this is an important issue. Knowing about the channel state information, because you need to control the power at the transmitter, whether you are having a good channel or bad channel. So you need to go for power allocation like that. So that's again an important issue to know the channel state information. And development of electronic and hardware is another issue. There are many such radio footprint development and many issues are there where the data-driven analysis is essential, and we have to go for machine learning approaches. So I end with this slides that research issues for the future communication is like this: energy harvesting to provide to enhance the network lifetime, then energy efficiency in presence of security. These are different security attack I didn't talk about, which we have make use in our work. Primary, which are emulation attack. Spectral sensing data falsing, mislead about the spectral sensing. Then if it is a long distance communication, we have to go for multi-hop routing, and we have to use reinforcement learning for getting more and more about the individual link to know. Then we need to go for, to know about the spectrum uses, we have to go for spectral sensing, cooperative spectral sensing, and in presence of several security threats. Then integration of all these like spectral sensing, energy harvesting, physical layer security, these are all challenges. Power allocation, jamming selection, counter measuring of eavesdropping, all these are issues there, and they need to be taken together in the system design, and an integrated communication system needs to be developed, which take care of spectrum, bandwidth, energy, data rate, latency, all in a single platform. Thank you. This much. That's all.
Thank you, sir, for your presentation. Faculty members, if you have any question, put it on chat box.
Okay. Or you can directly ask me. I think, okay, you can write in chat box. If you have any question or any point to, or any, if you like to comment on any issues, I would be happy to know or get it from you. If you have any comments or any points which need to take care, or any comments about my any comments from my end, whatever I made, which you do not like, or I mean do not agree up with, so you can share.
Any question?
Yes, somebody's of. See, this is all basically 5G and all. Even this technology is not yet being mature. The promise and the potential what you expected in the 5G, these are not again the matured, and this is not even in a form of this. So it's basically the facilities and all which support data rates or sort of things, underground technology, whether it is a 3GPP or LTE mode and all, basically like this. Nothing, I mean, in that sense that 5G, in fact, this always say that there are requirements like data rate 1 to 10 gigabits per second, volume of data traffics 40 terabits per month, like that, or latency of the order of 1 millisecond. So all these are not even being standardized, and the customer not being provided. The groups are working on and like. Any other points? Energy harvesting, very critical one. DC obtained from collected power from ambience very low. Yes, that means RF energy, what you like to say is very small. It's not like that. RF energy, there are TV towers and lots of other, I mean, billions of nodes, wireless nodes are there, and they are continuously emitting the RF. If you say this is very small, the global warming, the temperature is going on, that's again an issue. So what is not thinking in the sense that harvesters, what one need to do, that harvester circuit development is essential. And there are lots of works going on, linear and non-linear model of harvester circuits. So, and once the signal, I mean, the power is, the power consumption is going also reducing. Basically, it is a RF signal to DC converter. It's a kind of rectifier like circuit. So what is point to today? But people are working. A large set of people are working on the harvester circuits, and efficiency was also increasing. So that way, matured. In fact, in our India also, IIT Delhi group, Professor Sadish, this group, they people work on harvester circuits, and it's now becoming mature. High efficiency. Yeah, no, that's okay. I mean, this part is basically the issues of the harvester circuit. You, as you say, it's correct. But the people are continuously working on, and in fact, the efficiency of the harvester circuit is also gradually being increasing. That's true. I agree with that point, but the progresses are going on, and those people are working on harvester circuits. There, I know one research group of, in Southeastern University, USA, the research group led by Kaushik Rai Choudhury. They are working on this circuit part also. From ambience, there are maybe, along with the RF signal, there are non-conventional signal also. Maybe with respect to that, it's okay. But if it is a base station or TV tower station, this RF energy adjacency, I mean, closer to this, the RF power is fairly good enough for this harvesting. Basically, we do not directly work on the circuit part. Basically, we go for modeling and simulation aspects. But the point that you raised, that's really, I mean, that's true. That's true. But people are also working on that. Any other issues or any other point? Any other point?
So I think there is no more question. So thank you again. The session was very informative and insightful.
Thank you. Thank you for your invitation and thank you.